Hello, my name is Mr. Futrell. Welcome to Geometry class. This lesson will cover Chapter 1.1, Patterns and Inductive Reasoning, pages 3 through 9 in your textbook. Whenever you hear this sound, we are discussing an important definition. Before we begin this lesson, please make sure that you complete the diagnostic exercises on page 2. From Algebra 1, you should be able to add and subtract signed integers, evaluate a sum of squares, and evaluate a sum under a radical. In this lesson, you will learn how to find and describe patterns, and how to use inductive reasoning to make conjectures. Let's begin by describing a visual pattern. Look at example 1 on page 3. Can you sketch the next figure in the pattern? Each figure in the pattern looks like the previous figure, except a new row of squares is added to the bottom. Each figure looks like a stairway. So the sixth figure in the pattern should have 6 squares in the bottom row. Now let's look at example 2a on page 3. We are asked to describe a pattern in the sequence of numbers, and to predict the next number. We see from the pattern 1, 4, 16, 64 that each number is 4 times the last number. So the next number should be 4 times 64, which is 256. Now look at example 2b. Describe a pattern in the sequence of numbers, and predict the next number. If you subtract each number from the next number, you will notice that multiples of 3 are added to each successive number. In between each number, we add 3, 6, 9, so we must add the next multiple of 3, which is 12, to 13, in order to obtain the next number in the sequence. Thus, we obtain 25. Much of the reasoning in geometry consists of 3 stages. In stage 1, we look for a pattern by looking at examples, and using diagrams or tables to discover a pattern. In stage 2, we use the examples to make a conjecture. A conjecture is an unproven statement that is based on observations. Then we discuss and modify the conjecture as needed. In stage 3, we use logical reasoning to prove, or verify, that our conjecture is true for all cases. We will learn how to prove that a conjecture is true in Chapter 2. Inductive reasoning is a process of looking for patterns and making conjectures. Now look at example 3 on page 4. We are asked to complete this conjecture. Let's apply inductive reasoning to solve this problem. First, let's look at some examples. The first odd positive integer is 1. Let's look at the sum of the first 2 odd positive integers. 1 plus 3 is 4. The sum of the first 3 odd positive integers, 1 plus 3 plus 5, is 9. The sum of the first 4 odd positive integers, 1 plus 3 plus 5 plus 7, is 16. 1, 4, 9, 16. Do you see a pattern? The sum of the first n odd positive integers is n squared, since 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Thus, it must be true that the sum of the first 5 odd positive integers is 5 squared, or 25. Let's check this. 1 plus 3 plus 5 plus 7 plus 9 plus 11 is 25. So our conjecture appears to be valid. It is very important to note that in order to prove that a conjecture is true, you must prove it is true for all cases, not just a few examples. However, to prove that a conjecture is false, all we need is one counterexample. A counterexample is any example that proves that a conjecture is false. Look at example 4 on page 4. We are asked to show the conjecture is false by finding a counterexample. The conjecture seems to hold true for all integers. However, the conjecture mentions real numbers. Remember from algebra that a real number is a set of all numbers, including integers, rational numbers, and irrational numbers. So let's take a rational number, like 1/2, and test this conjecture. We know that 1/2 squared is 1/4, which is less than 1/2. Thus, we have found a counterexample which proves that this conjecture is false. Inductive reasoning is important in the study of mathematics. But remember, just because something is true for a few cases, does not necessarily mean it is always true. We will learn more about proving a conjecture is always true in Chapter 2. This concludes Lesson 1.1. We have learned how to find and describe patterns, and use inductive reasoning to make conjectures. The important definitions in this lesson are conjecture, inductive reasoning, and counterexample. For homework, the CP classes should do page 6, problems 13 through 31, odd, and 47 and 48. The honors class should do problems 13 through 39 odd, 40 through 43 all, and 47 and 48, and also read exercises 5 and 6 on page 5, and use Google to look up the exact definition of a prime number, the Goldbach conjecture, and the Ishango bone, that is, I-S-H-A-N-G-O, Ishango bone, B-O-N-E. Thank you.